Determine if the series converges or diverges. We have 1 divided by square root 3 minus 1 divided by square root 4 plus 1 divided by square root 5 minus 1 divided by square root 6, and so on. Let's begin by writing sigma notation for the infinite series. Let's let the index be n equals 1 to infinity. Ignoring the alternating sign for a moment, notice all the numerators are 1, and notice the radicands in the denominator increase by 1 each time, starting with the value of 3. So when n is 1, notice 1 plus 2 is 3. When n is 2, notice 2 plus 2 is 4. We can write the denominator as the square root of n plus 2. And now to deal with the alternating sign, let's try a factor of negative 1 to the power of n in the numerator. This actually isn't correct. Notice when n is 1, we get negative 1 divided by square root 3. We want positive 1 divided by square root 3. So we'll change the exponent on negative 1 to n plus 1. Now notice when n is 1, we do have positive 1 divided by square root 3. When n is 2, we do have negative 1 divided by square root 4, and so on. And now because we have an alternating series, we'll apply the alternating series test, shown here on the right, where to begin we determine a sub n, the non-alternating part of the formula, and then the series converges if the limit as n approaches infinity of a sub n equals 0 and a sub n plus 1 is less than or equal to a sub n, meaning the non-alternating terms are decreasing. Looking at our formula, notice a sub n, the non-alternating part of the formula is 1 divided by the square root of the quantity n plus 2. And now for the first step, we determine the limit as n approaches infinity of a sub n. As n approaches infinity, the denominator increases without bound, the numerator stays 1, and therefore the fractions get smaller and smaller and approach 0, indicating the limit is equal to 0. So the first condition has been met. And now for the second condition, we need to verify that a sub n plus 1 is less than or equal to a sub n. Using the formula for a sub n, notice a sub n plus 1 is 1 divided by the square root of n plus 1 plus 2 over n plus 3, less than or equal to a sub n, which is 1 divided by the square root of the quantity n plus 2. When comparing two fractions with a numerator of 1, the fraction with the larger denominator will always be less than the fraction with the smaller denominator. And notice the square root of n plus 3 is greater than the square root of n plus 2, and therefore 1 divided by the square root of the quantity n plus 3 will always be less than or equal to 1 divided by the square root of the quantity n plus 2. The second condition has been met. The series converges by the alternating series test. I hope you found this helpful.